Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily lead code problem, and the problem's name is number of steps to reduce a number in binary representation to 1. So you will be given the binary representation of an integer in the form of a string s, and then you have to return the number of steps to reduce it to 1 under the by the following operations or under the following rules. If the number represented by the current binary representation is even, then in that case you can divide it by 2. Okay, and if the current number is odd, then first of all you have to make it even by adding 1 to it. Okay, both of these operations will take one step. Okay, so it is guaranteed that you can always reach 1 for all test cases. Okay, so let's have a look at the constraints also before thinking of an approach. So the length of the string is of order 500, and it consists of two letters only, either 0 or 1 characters you can say, and first character of the string is always 1. Okay, so let's try to make sense what this divide by 2 operation will do. Okay, there is a little observation that you can make in order to solve this problem. What is that observation? Now let's take a binary number. So what does you know divide by 2 basically does? So what it basically does is it left shifts the bits by one place. Right shifts, pardon please. So what I mean by right shift, if you divide this binary number by 2, its decimal equivalent by 2, then the binary representation will look something like this. Okay, so as you can see, this bit is shifted to right. All these bits are shifted to right by one place. Then again divide by 2. So again this will be shifted here. This will be shifted here. So 0, 0, 1, 1. Then again divide by 2. Then again this one will be shifted here. This one will be shifted here. So it will be gone 0, but not 0 exactly. It will be 1, 0, 0, 0. Okay, so this is how everything will keep going on, and we will stop once we have 1 at the 0th position. Okay, so the first observation that we made is dividing by 2 is just shifting bits 1 towards left. Okay, 1 position towards left. So divide by 2 is equal to right shift by 1 position. Okay, and there is another observation that can be made. If the bit at the 0th position is 1, it means that this is the 0th position, first position, second position, and third position. Okay, so if the bit at the 0th position in binary representation is 1, that means that number is odd. In that case, not only dividing by 2 will be sufficient, we have to first make it even. Okay, in order to make it even, what you will be doing is you will be adding 1 to it. Okay, now adding 1 will generate, if you are familiar with binary representation of numbers will generate a carry. Okay, but you know, and that carry will be taken forward to the next bit. Okay, so if the if a bit is set, okay, it will eventually come to the zeroth position. I mean, if let's say we are having a number, binary number, something like this. Okay, eventually this number and this bit and this bit, which are set by the way right now, will come at the position or zeroth bit. Okay, how so? We will keep dividing this number by 2 and these bits will keep shifting to right by one place. Okay, and this entire thing will stop when the leftmost bit is at the zeroth position. Okay, and it is mentioned that the leftmost bit is always set in the given binary representation because of this constraint, that the first character is always 0 in the string that is representing the binary representation. Okay, so it's like just like we are having a magnet kind of thing here, and this magnet is pulling, you know, these ones, or these ones are irons, one pulling them towards this direction, one bit position at a time. Okay, so after the first pull, your binary representation will be something like this. Okay, and after the second pull, it will be looking something like this. Okay, now you see that here at the zeroth bit you have 1. Okay, so it means that the current number is odd number. In that case, you should be you should be adding, or oh, adding one more step in order to convert it into a even number. Okay, so it will generate one extra step of converting it into a even number. So in total, if you see how many steps will be needed to turn off this bit. Okay, we are not talking about this bit right now. If we are worried only about this bit, how many steps needed? So you can see that 2 steps are needed. One is divided by 2, which is okay, but one is when this will reach the zeroth position, irrespective of whether whatever it was its current position. So if a bit is set, it means it is 1. You will require 2 steps. Okay. Now there is a little observation, one little more observation that you have to make. What about these zeros? How much steps will be required? If there is a 0, we are told for sure that the first leftmost bit is always set to 1. Okay, so this will be traveling some places. Okay, let's say all these are zeros. So how many number of shifts required by this 1? You can see that 3 shifts, which are these zeros only. So each 0 will contribute to one operation. Okay, because of this magnet pulling. Okay, each 0 will contribute to one operation. Two operations contributed by 1, and 0 will contribute only one operation. Okay, so there is a little edge case, or you can say thing that you have to keep in mind. After the very leftmost set bit, which is the 0th indexed character in the given string, which is by the way always set to 1, for that 1 we do not have to add 1 to it, because when it is the only bit left in the string, after this magnet have pulled away all the remaining ones. Okay, So when after this case, you will be having something like this. Okay. So it was the very leftmost bit that is now at the 0th bit position because of this magnet pulling. Okay. When this is happening at that point, you will just stop. You do not have to add 1 to it, even though it is a odd number, but our goal was to just form 1, which is itself a odd number. So in that case, you will stop right there. Okay. So what we can say that by this observation, that we have to exclude the very first bit or the 0th indexed character of the string from counting the steps or towards contributing towards the steps that are required to make this entire number equal to 1. Okay. So starting from the very last position of the string, so if we, you know, take a fresh slide and let's say this is the string given to you. Okay, and this is the string basically. So if we talk about bit positions, that we will be moving from right to left: 0th bit, first bit, second bit, third bit, fourth bit, fifth bit. Okay, so these are bit positions. But how will the zero based indexing of the string will go? It is from right to left. Okay, so when the magnet will be pulling to from the 0th bit side, we want to traverse from right to left. Okay, so we will start our traversal from this direction, right to left. Okay, and if the current bit is set to, let's take one of those examples so that we can verify our answer whether it's correct or not. So let's take this one. Okay, so it is 1101. Okay, let's take another slide. 1101. So let's mark the bit positions: 0th bit, first bit, second bit, third bit, and let's mark the indices also: 0, 1, 2, and 3. So we will exclude this bit as we discussed, because this will result into 1, so we need not have to count it. So we are only concerned about this much portion of the given string. Okay, so first of all we will see how much this one will contribute. Okay, and we will have another variable which is carry. Okay, so we will see what is the bit. So it is 1 plus our carry. Carry right now is initially equal to 0. Okay, so we will see what this results into: 1 plus carry. So 1 plus carry will be 1. If 1 plus carry is equal to 1, it means that, you know, eventually this number will contribute to two operations. Okay, one is divide by 2 and another is plus 1 to make it even. Okay, so two operations. So during these two operations, when you will be adding 1, so 1 plus 1 becomes 1 and 1 is taken to carry on the bits towards the left. Okay, so let's say the binary representation was something like this. So 1 is taken towards carry towards the left. So in that case, if this is equal to 1, this term is equal to 1, in that case your carry will again be 1. Okay, and then you will check for the next position, which is this, or the next index, which is this index. So this index, although the character at this index was 0, but when you add carry to it, it will again become equal to 1. So now it again became equal to 1. What you will be doing now? So this thing will again contribute to operations. Okay. And now this will be contributing to two operations. So then you will be moving to this bit, and carry will still be equal to 1. Okay. So now your current bit will be 1, which is the first indexed character, and carry will also be 1. Okay. So in that case, uh, you will see that it is no longer equal to 1. It is equal to 2. Okay. So what will happen in that case is, so in that case, your, you will know that it will result into a 0, because carry will although be carried forward, but when you add this 1 with 1, it will result into 0, and 1 is again carried as a carry. So although carry will not be changed, it will still be 1, but we talked about that 0 will result into one operation only. So what it will result into is, the number of operations will now, instead of increasing by 2, will increase by only 1. Okay. So then your carry will be, 1, and then we will stop. Okay. So how many number of steps? So if you count the number of steps, they are plus 2, again plus 2, and then plus 1. So in total 5 steps. But you may notice that carry is still 1. Okay, so it will add to some number. Eventually that number also will lead to some operations. So you have to take into account carry also. So carry is right now 1, so you will add carry, which is 1. So 5 plus 1, it will be total 6 steps. Okay, so let's see the answer whether we are correct or not. So yeah, we are correct. So there are total 6 steps. Okay, so let's have a look at the implementation quickly. So implementation is pretty much same as I explained you in the with the example. So let's take it to another slide. So this is the implementation. So what we are doing here is, as we talked about, that we will be starting from right to left direction. Okay, and we will be ignoring the very first bit character from left hand side, because it will make the string equal to 1. So from the size -1 to the first index we will consider, and from right to left direction. If the current bit, okay, this will result into 1 or 0, depending upon whether the current bit is 1 or 0. So 1 will result into 1, and 0 will result into 0. Okay, plus carry. Carry will initially be set to 0. If that happens to be equal to 1, then we will know, okay, for sure, if a bit is set to 1, it will contribute two operations. One will be to make it even when it reaches the 0th bit, which is by adding 1, and another will be to divide it by 2, to just remove that bit completely from the binary representation. So two operations in total. So in that case, the number of steps that will be required will be increased by 2. And another thing that you must keep in your mind is that carry will still be equal to 1. Okay, so carry will still be equal to 1. And if that is not the case, that this entire thing is not resulting into 1, then you know that okay, for sure it will be a 0. And for zeros we already know that contributes only one operation. Okay, so that is just because of this magnet pulling, so it will contribute to just one operation. So steps will be increased to only one times. Okay, and then at last you will return steps plus carry. Why carry? Because it might happen that after you are done with this loop, carry will still be equal to 1. So that bit is needed to be taken into account. So that's why steps plus carry we will be returning. So this is how we will be solving it. And if you talk about the time complexity and the space complexity, you might have guessed it's quite easy to analyze the complexities in this one. But still, time complexity will be order of size. Okay. And space complexity wise, you might have noticed that we are not using any extra space, so it will be constant, order of 1. Okay, so these will be the complexities. If you are still having any kind of doubts or any queries in general, then you may ask in the comment section. I hope this video solution added some value to your journey of owning your DSA skills. Till then, keep practicing and keep solving problems. I will see you in the next video. Thank you for watching.